Well, hello, Year 10. Can I just say the chat is very interesting. Yeah. I have to say, no. Sorry, other computer going crazy. Guys, very interesting chat about dragon fruit. Not entirely sure how that's going down, but all right then. Allergic reaction. Oh, face is gone. Oh, that's a bit worrying. Right, I'm going to do the register. Let's see who's here. Stop. I'm going to mute that. Right, so do we have Amani? I haven't seen. Oh, Amani's like third one in. Wow, that's not usual. Zach, haven't seen Zach yet. But there's Zach. Zach's in. Ryan's in. Sophia. Do I have Sophia? Anyone seen Sophia yet? I've got somebody I don't recognize as well. Tiffany. Tiffany's in the house. Kayla? Has anyone seen Kayla? The problem with you guys, I love that I've got Rania Halim. Hi, Rania. I don't know who you are. I still haven't seen Kayla. Have I seen Mel? Yeah, seen Mel. Audra? That's my sister's account. Oh, okay. Still don't. Oh, okay. Is that Sophia? Sophia. Okay. I've got Lara. Seen Rania is Sophia. Oh my goodness, that's so funny. Atia and Nanya have seen Caitlin. Have seen Caitlin? Yeah, seen Caitlin. Seen Dom. Seen Ryan. Seen Lynn. Libby. Have seen Libby? Oh, there's Audra. Where's Libby? Libby's in, and Halping's in, of course. Kayla. Anyone seen Kayla? Got Audra. Kayla, it's the only person that's missing now. Okay, I will leave Kayla then. Does anyone know? Anyone send her a message? That would be great. Okay, right, guys. All right, I am not going through your test quite yet. The reason being is tomorrow, my other year 10 class is doing their online test. So I will go through it next week, which will be Tuesday because we're off Thursday, Friday, and Monday. So it'll be on the Tuesday next week. So in fact, a week today, I'll go through your test just to make sure that everyone's on board. I have now made a second test. So anyone, I know that you've actually already had your results. The results are already in. You guys already know. Oh, hey, Ben. Ben's decided to make an appearance. Right, Ben, it's really funny. So I have made a second test, folks. So when we've been through the first one, if people would like to do a retest, it is available to you. Some people will have to do them. I'm not gonna bother trying to name who's gonna be naming. I'll talk about that on Tuesday. But okay, so does anyone still know about Kayla? Please keep me informed. Okay, right, guys. Today we're moving on to a new topic. We're moving on to acid-base theory. Ooh, it's very exciting. It's very exciting. Right. So, guys, you're keeping notes. I already know I have to retake the test. Don't think that's entirely true, Atia. Are you sure you can't go over the test now? I'm part of 10A. Sure you are, Toby. Hello. Sure you are. Of course. Yeah. They've totally dropped in today to see if I went through the test. As if I'm that stupid. I mean, come on. Anyway. Right, guys. There we go. We're there. So, acid-base theory we're starting today, guys. Now, the great thing is we have already done moles in solution. So, we've got a huge part of acid-base already ticked off. I'm hiding that, Dom. I'm not showing your message saying that what a bunch of losers. I'm gonna get rid of that. I just thought you might have forgot. I can't believe you've just done that. That's so sneaky. So sneaky. Oh, sneaky, sneakerson. Right, okay, guys. So today's lesson is on acid-base theory. Oh, wow, yeah. So we need to, first of all, remind ourselves, you guys haven't done proper acid-base theory since year 7. And that is a long time, and I'm very aware of that. So the first thing I'm going to be doing is going through key stage 3 acid and bases. Then we're going to be looking at, I need you to know the common acids and bases that you must know for Edexcel. And then I need you guys to understand the term dissociation. I'm actually going to add another word on there, association stroke ionization. Yeah, I'm going to add that one on there as well. Well, that's a bit wonky, isn't it? Okay, cool, guys. So key stage 3, acids and bases. Whoop, whoop. Right. So year 7. In year 7, you learned about, now, can I just point out, you probably got given the term acids and alkalis. I hate this. Absolutely hate it. Yeah, no, that is not okay. It should be acids and bases. There are 2 true families in chemistry, and those are acids and bases. And you don't, the alkali, the first thing I want to add in here. So there's my, it's so not as good as I thought it was going to be. There you go. Look at that. It's better. Right, guys, I've got a year 7, acids and alkalis. Can everybody, please, everybody on the chat, I want as many words as you can. That I've just looked at my laptop and seen the pause video of my face. It's terrible. Guys, can you give me every word that you can remember for acids and alkalis from year 7? Yes, that's right. From year 7. There we go. Give me some words, folks. Give me some words. Iodine. pH. Thank you, Ryan. That's the first one. Iodine. No. Indicator. Love it. Indicator. Bleach. Oh, like it. Look at this. Bleach. Green. I like it. I love the green brackets. Neutral. Like it. Next. Washing up. I like it. Washing detergent. Washing. I started writing the next word before I even finished the first one. Detergent. Is it detergent or detergent? Don't know. Universal indicator. Love it. I'm just going to put UI. You guys are going so fast, I can't keep up. Alkali soluble base. Love it. Alkali soluble base. Oh, you guys are going so fast, I can't keep up. Soluble base. Oh, I love it. I'm getting given acids. HCl. H3PO4. Phosphoric acid. Love it. Lemons. Oh, it's amazing. Water is green. Green, neutral, water. I like it. Phenol, neutral. Oh, God, you got neutral. Phenolphthalein. Wow. Did you get that in year 7? That's excellent. I do teach that. T-A-L-E-I-N. Phenolphthalein. Outstanding. 14 levels. pH brackets 1 to 14. I like it. Lemons. Red is acid. I like it. I'm getting colors. Yeah, acid. Where's acid? Acids. Whoop. Red. Yeah, that was terrible. I can't do it. Red. What else have I got? Blue is alkali. Yeah, I love that. Blue. We've got alkali. Yeah. Purple. I love it. We've got purple. Wow, you guys know a load of stuff here. Corrosive. Yes. Love it. Corrosive. What else have I got? Sonic on steroids. Wow. Melanie. Ooh, that's posh. H+/OH-. That's not year 7. Dilute. Ooh, like that. Dilute. Next, boric acid. Wow. I don't know how you guys know that. Nitric acid's made an appearance. Love it. That doesn't look like a 3. Needs to be a 3. Wow, look at this. Sulfuric acid. Yes. H2SO4. Winner. We should make another heart. purely of Lynn's beautiful contributions. What was Lynn's contribution? Of what? Nothing. Rainbow. Love it. Love it. Concentrated. I like it. Concentrated. Ah, you guys have so many words. Did you say carbonic acid? Ostwald process? Oh, helping. Ledge. Carbonic acid. I love it. And then the Ostwald. Where's nitric acid? Ostwald. It's Ostwald, isn't it? Ostwald. That'll be his name. Weird. Ostwald process. If you're interested, the sulfuric acid is called the contact. You need that one. Contact process. Don't actually need the Ostwald. Right, guys, that was amazing. Like, chuffed to bits with that. Guys, please freeze your screen because that is an amazing picture. Right, I'm going to flag up all the ones that I do not believe are year 7. H plus and OH minus. Definitely not. Carbonic acid, definitely not. Phenolphthaleins, not usually. Phosphoric, no, think not. Might have had the, well, yeah, definitely the Ostwald process and contact process. But everything else is year 7. I really liked it. All alkalis are bases. Yes, that's correct, Sophia, absolutely. But not all bases are alkalis. Water is peace because it's neutral. I'm just gonna walk away at that point. Okay, so guys, can you please note down key things to take away? It's actually key things to take away from year 7. So there are, now don't get me wrong, no, water is Switzerland. Acid is sour. Ryan, you're absolutely right. Acid is sour. That is a property of acids. It's one that I'm now going to tell you to delete. But it is correct, absolutely. So key things to take away from year 7. So number 1, can you please put acids? So I've been adding acids to your repertoire since year 9. Oh, Ryan, you actually deleted it. That's amazing. Ryan, that property of sour is just not now needed at GCSE. There are other properties that now take over, corrosive being the one that they want. Oh boy, I wonder if acid is sour. Let me just land a drop of HCl on the tongue. Lynn, that is really not a good idea. It's a really bad idea. Like, I've tasted hydrochloric acid. In fact, I've tasted all of them. Please don't do that, by the way. It's not safe. But like, even dilute is scary. Like, it makes your teeth feel rotten for weeks. They're really bad for your teeth. They do have different tastes, though. Rather interesting. Don't ever do it. It's a terrible idea. Wait, why? I did it because I just wanted to know, Lynn. And it was me being a stupid kid. It's not something I'd recommend. Tried citric acid power 1. Yeah, that was intense. Nice one, Libby. So guys, key things you need to take away. Acid, number 1, is hydrochloric. You need HCl. Now we need to add details onto this. Yeah, my tongue went numb. Oh well, look, this strange liquid I've found. I wonder what the pH is. I don't have university. Better just taste it. Yeah, that's a really bad idea. Yeah, I mean, yeah, let's move on. So HCl, chemical name is hydrogen chloride. You guys will recognize this. Hydrogen chloride. Now, the only time you ever call it this is when you have HCl as a gas. If you have HCl gas, then it is hydrogen chloride. But then you also then have hydrochloric acid. And of course, you call it hydrochloric acid when it's HCl aqueous. Yeah, key things there for HCl. Next, acid number 2. You should have got these all at year 7. So you get HNO3. And this is nitric acid. Nitric acid. Now, you guys will never deal with this on a concentrated level, so you never need to know the other alternative. Just so you know, if anyone's interested, nitric acid is HNO3, and it's actually a liquid at room temperature. Hydrochloric acid is a gas at room temperature. Sorry, hang on a minute. If you're going to call it an acid, it must be aqueous. And then if you just have, otherwise it would be hydrogen nitrate. Hydrogen nitrate, if it's without water. HNO3 liquid. Yeah. Next one is acid number 3, which is H2SO4. You've got to know this one, folks. H2SO4, I think everyone here knows the name of. Yeah, this is sulfuric acid. Sulfuric acid, and of course, that's when it's in water. I'm going to add that note on in a second, folks. Aqueous. Aqueous means dissolved in water. Yeah, and this would be hydrogen nitrate, hydrogen sulfate, spelt with an F. Yeah, if it was, and by the way, sulfuric acid is also a sticky liquid when it's at room temperature. Hydrochloric acid is the only gas there. I've realized that I haven't kept continuity between the columns. Apologize. There are many other acids. Now, I'm just going to give you the extra ones that you guys have mentioned. So, number 4. Now, these are beyond GCSE. Yeah, all of these are sticky, icky. Yes, actually, Atia, it really is. It's a funny stuff, concentrated sulfuric acid. Concentrated literally means without water. Just going to make a note of those. Yeah. When you hear the word concentrated nitric / sulfuric, the word concentrated literally means without water. And it's a bit of a nightmare, this, but you guys will never deal with this stuff. The first time you deal with this is at A-level chemistry, because it's such dangerous stuff. You know, those things, like if you got them onto your skin, it's actually, you have moments to wash it off before it burns you. But if you got it into your eyes are gone. Yeah, there's no delay. It's not nice stuff. Acid number 4, you mentioned carbonic. H2CO3. This is called carbonic acid. Now, carbonic acid is what's in fizzy drinks. And by the way, yes, it must have the aqueous sign. At this point, I'm going to make the nota bene, folks. I'm actually going to make this bigger as well. So NB, nota bene. Why do we have it so it's so dangerous? Ryan, we need it. We use it for all kinds of good chemistry. Yeah, so you're going to learn when you get to year 11, you'll start learning of some of the uses of these concentrated acids. So concentrated sulfuric acid is the catalyst required for making esters, for example. And they do actually have functions. Is it sulfur also? It's spelled with an F. The pH is an ancient English misspelling. Mr. Duncan, is it true that when you dilute acid, you cannot add water to acid, but you have to add acid to water? Lynn, where have you come across that? Have I taught you that? The answer is yes. Whenever you dilute any acid, you always add the acid to water. You never go the other way around. The reason being is if you add acid to water, the process is actually very exothermic, which means you can actually boil it. I've got a really cool demo where you add water to sulfuric acid and I can boil it. It's a really cool demo, actually. You can actually get the temperature up so hard you can boil the water. Nota bene. So this is quite important. An acid, isn't that funny? Start writing alkali. An acid stroke alkali are not acid or alkali unless in water. I cannot tell you how important that is. An acid or an alkali cannot have those properties. What is carbonic acid? And that's not a Q form. What is carbonic acid? That's not a Q form. Ooh, hydrogen carbonate. That's a good question. I actually don't. I want to say it's a solid. I've never seen it. Tiffany, it's a really good question. I've never seen it. I've never seen H3CO4, H2CO3 as anything other than aqueous, because you don't tend to use it. Like, that's a really good question. You've just beaten me. Wow, first time in a long time. I'm gonna have to look that up now. Carbonic acid, by the way, you can add this to your notes. So, by the way, that I cannot stress to you the importance of that. Acids and alkalis cannot be acid and alkali unless they're in water. I'm going to make this medium. So, carbon dioxide, we know we're producing from combustion. I love it when Mr. Duncan doesn't know something. Thanks, Atia. Thanks for that. What would it be called? It'd be called hydrogen carbonate, is what it'd be called. Thanks, Atia. I suddenly realize how mean that is. Can I just tell you how rare that is in my world? It's so rare to be beaten at here, and I love being beaten because it means I have to do the research now. I'm going to say that that's a solid. I've no idea. I think it's a solid. No idea. I've just never come across it. Carbon dioxide plus water goes to H2CO3. So one of the reasons, so this equation here, yeah, we know that we're producing carbon dioxide from the combustion of hydrocarbons of carbon. I should actually put hydrocarbons, coal, etc. We know that this is causing, we know that this CO2 causes global warming. Yeah, and that's what you write down at GCSE. Global warming. Yeah, but another consequence is that the carbon dioxide is dissolving in the ocean. So the ocean is becoming acidic. Yeah, ocean is becoming acidic. Now, can I just point out, this is a very slow process. This is not like acid rain kind of acidic. It's just making the ocean's pH drop. That's all. If they ask you for the problem environmentally of carbon dioxide, you always choose global warming. Yeah, that is the environmental issue is global warming. We don't talk about the acidifying of the oceans yet because it's not become more important than global warming. So it kind of just takes preference. Other acids that you've mentioned. Somebody mentioned boric and phosphoric. Phosphoric acid is at A level, H3PO4. This is phosphoric acid, by the way, and phosphoric acid, yeah, that's aqueous. The phosphoric acid without water is a liquid. It's a sticky liquid, like sulfuric, and that would be hydrogen phosphate, is what that would be called. Yeah, H3PO4 liquid, no water, is hydrogen phosphate, and it is a liquid. So I know that one, I just don't know carbonic. How about ethanoic? Oh, Lara, check you out being sneaky. All right, number 6, I'll give you that one. Can I just point out that's way more important than boric? You don't even need to know boric acid for forbidden. Can I drink that? You guys have lost it. Are you guys okay? I'm worried about you. Like, you've completely gone off piste. It's a mental. Ethanoic acid. Now, this one's far more. It's a lot different than the others. Can I just point out that this one here, this is called ethanoic acid. Any of you guys that remember your naming from last year, you'll kind of see the eth in this. Yeah, this is ethanoic acid. By the way, ethanoic acid is also a liquid at room temperature. In fact, I apologize. That would be aqueous. Yeah. You're not going to like this. So ethanoic acid is what it's called in water. Vinegar. Yeah, that's correct. Common name. Yeah, common name is vinegar. Well done. Common name is vinegar. It has another common name as well. Common name is vinegar. The other common name is acetic acid. Old name. Isn't that funny? There's an old name This one here is the old name. This one here is the what's called the common name. And this one here is the IUPAC name, the International Union of Pure and Applied Chemists. Isn't that cool? 3 names all for the same stuff. You're not going to like this. Now, can I just point out that organic acids are kind of special? Quarantine does things. Quarantine does something, that's for sure. Vinegar, sour sauce. Oh my goodness. Yeah, that's not the common name. Oh my goodness. Sour sauce. You're not going to like this, folks. So ethanoic acid can, of course, be concentrated, and it's a liquid. Yeah, and it does have a different name. Xiaolongbao sauce. Nice. Oh, related to acetate. Yes. Atia, how do you know the word acetate? Acetate is the name of a salt made from ethanoic acid. Are you talking about the acetate sheets that you use in school that projectors used to use? Blimey, acetate. It's a type of polymer, that one. Comics. Huh. Yeah, comics are wrapped in acetate, wrapped in a type of plastic that has the structure of vinegar inside it. That's correct. Wow. I'm almost tempted to show you that. I won't go nuts. Right, guys, this liquid is, you can't call it acid. Probably in Dasani water. This is called glacial. Glacial acetic acid. I know, it's the glacial bit that tells you it's concentrated. Sorry about that. By the way, you're asking things which are so far off piste. It's part of AS chemistry. You come across glacial acetic in practicals because they have to use it. What a name. Yeah, do you know the word glacial? Do you know the word glacier? Why is it called an acid? It's a very, very good question. Don't acids need water? Yes, you could just call it glacial acetic. They'd allow you to just say glacial acetic. You wouldn't. You would add the acid in just because you can. But yeah, funnily enough, it is called glacial acetic acid. It just is. Big ice. Yes, Ryan, well done. A glacier, a glacier. So I'm gonna see if I can find a picture for you. Guys, glacial, do you know what? You'll figure this out. Glacial acetic acid. Check this out. That has not worked at all. Glacial, ethanoic acetic acid. Check out the images. The reason why it's called glacial. This is where I really need someone to have posted a really nice picture, and people haven't. I apologize. There. Yeah, glacial acetic acid. One of what tends to happen. Ooh, it's pretty. What tends to happen inside the bottle? I'm trying to find you a better picture. Oh, do you know what? It's really annoyed actually because I've got pictures saved on my pen drive that I've actually taken myself of glacial acetic, of concentrated ethanoic acid. It's really annoying me actually how I can't find any. It looks like that. It's because what happens is that crystallization. Yes, Tiffany, it is. It looks like ice. That's helping. That is exactly why they called it what they did. So in terms of the picture, if we have in school some glacial acetic. So if you have a bottle of glacial acetic acid, and that's just concentrated, what tends to happen is you have these iceberg-like structures floating around inside it. It looks just like that. So you end up with these iceberg. I can't even spell berg. How do you spell iceberg? Is it like that? RGE. Iceberg-like structures. How do you spell berg? Frozone. Yeah. Is it edible? Oh my God. Iceberg. Ah, thank you. Iceberg. E-G-E-R-G. Thank you. Iceberg-like structures. Thank you, guys. And this is because ethanoic acid has a melting point that's very close to room temperature. And so what that means is if you've got it in a certain temperature, you start to see these like iceberg-like structures, and they called them glaciers. They called them icebergs, and they called it glacial acetic acid. Acetic iceberger. Yeah, I think that's what I was trying to write down before, Atia. Yeah, same, haha. Yeah, that was definitely my fault. Iceberger, he says. Yeah, I know, all right. Yeah, I know. Iceberg lettuce, yeah, maybe. Anyway, so it's kind of cool stuff. I've got some photos, as I said. I've got some really cool photographs of times when I was just, oh, look how pretty it is. It forms such beautiful crystals. Really beautiful crystals. Trying to find some more really good examples where you see these gorgeous, like they almost have like, they're such pretty crystals. They have like really distinct shapes to them. Like they're like rhombic kind of big, like spiky crystals. It really, really cool. If you zoom in on the icebergs, you have these like rhombic style crystals coming off them. It's really, really beautiful. They have some like, it is amazing when you see it. And they called them icebergs. Yeah, they called it glacial. Really, really beautiful stuff. I love going off on a tangent. Like bismuth. Yes, Libby. So, Libby, one of the things that we don't teach at GCSE or at A-level is what's called crystal lattice theory, which is you realize that all things form crystals. So do you want to see some really amazing ones? So gold crystal. I've always wanted to add this to my collection, although I don't ever think you can buy them. But gold forms amazing crystals as well. Like, look at that. Isn't that amazing? They have shapes and structures. What about an amorphous solid? So amorphous solids are like glass. Amorphous solids tend to be singular crystals in reality. Yeah, they're a bit more complicated, Libby. I'm happy to like give you a lesson on that if you like. Somebody said mercury. I don't ever remember seeing mercury as crystals because I have made solid mercury. If you cool down mercury to about -70, it becomes a solid. Crystal mercury. I don't know what crystal shapes mercury makes. Let's have a look. Okay, that's definitely not what I wanted there. Let's try that mercury metal. I've never seen the crystals it makes. Oh, look at that. Gallium? That's not mercury. There might be a reason why I've never seen mercury as a crystal. No one ever really does it, I guess. Mercury, of course, being a liquid at room temperature just means that you don't ever tend to see it as a solid. Liquid mercury, no. I've never seen mercury as a solid grown into crystal structures. It wouldn't remain there, Sailor Moon. Is that what that was? That is very much adequate. I don't really know what that means. I don't know on the chat. I don't know. Anyway, let's get back on topic. Okay, so you form this glacial acetic, which is rather lovely. And all of these acids you need to know for GCSE. Carbonic acid, by the way, carbonic acid has been asked at GCSE. Yeah, which I thought was lovely. Has been asked, yeah. Phosphoric does get asked. You need that as that is the catalyst for the production of ethanol. You guys need that one at GCSE. Totally correct. And ethanoic, absolutely. You don't need to know its formula, just a name, but it's worth learning it. Makes life easier when you step into A-level. Okay, the next thing is, guys, we need to name our bases. So let's do our bases. Bases. So, guys, on the chat, please, can you guys give me some bases that you remember from year 7? Give me some bases. Who can give me the top number 1 base? It'll be the first on the chat, I bet you. The first one on the chat will be the one I want. It's really tempting to pause my screen, write down what I know you're going to say on the chat, and then put it up. But who's going to give me? That's the one. Thank you, Halping. Well done. Halping got the first one. And this is the most important, really, that you need. Sodium hydroxide. Yeah, sodium hydroxide, formula NaOH. It is a solid, by the way. It is a solid at room temperature, and you don't call it anything different. Yeah, you don't call it anything different. Just NaOH aqueous is still sodium hydroxide. Isn't that funny? The alkalis are different, totally different families. Number 2, well done, folks. Really impressed with Lara giving me ammonia. Well done, outstanding. Ammonia. Do you know that this is the most important chemical in the history of mankind? NH3. It's used to make fertilizers. And by the way, ammonia is a gas. Yeah, ammonia is a gas. It's not a base until it goes into water and you get ammonia aqueous. Yeah, there we go. Next, number 3, I loved your example of calcium hydroxide. What a great one, Ananya. Outstanding. Do you know that this has a common name? Calcium hydroxide. This one has a common name. It's called slaked lime. Slaked lime. Just to point out, I think the others, toothpaste. Yes, it contains calcium carbonate as a base. Yes. Just to let you know that sodium hydroxide also has a common name. It's called lye. Washing detergent, I guess. Yes. This is called lye. I don't know how to spell lye. I think it's literally spelled like that. I might be wrong there. But common name for sodium hydroxide is lye, or caustic soda. It's called lye, or better, caustic. This is the common name. Caustic soda. That's a better one. I think I might be wrong with lye. That might be potassium hydroxide. Slaked lime. Ammonia doesn't have one. Ammonia already is a common name. Nitrogen trihydride. Washing up. I don't know what. I love the fact that I have no idea what Martand now has to say. Lye. Thank you. Can you just check for me? Is lye? I think lye is correct. Lye is sodium hydroxide. Potassium hydroxide is given a different name. What's potassium hydroxide? You use it when you're making soap. Sodium bicarbonate, absolutely. Number 4, calcium carbonate, so important. Calcium carbonate is a base. Yeah, carbonate. All carbonates and all hydroxides. No, sodium carbonate is as well, Libby. You were absolutely right when you said it. Yeah, it really was. So number 5, sodium carbonate. I think you said sodium carbonate or sodium hydrogen carbonate. Na2CO3, absolutely. All carbonates. Here's your nota bene, folks. You can keep this red, nota bene. Nota bene. And you can add this to your book. Let's make that thicker. I've zoomed out, obviously. Nota bene. All hydroxides and carbonates, magnesium hydroxide. Yes, absolutely. All hydroxides and carbonates are bases. They're not all alkalis. Just be careful on that one. Yeah, calcium carbonate is not soluble. Yeah, calcium carbonate, this is a base. Base, yes. Alkali, no. It's not soluble. Yeah, not soluble. Okay, so now that we've covered like a lot of the bases that we need to have, you can also have any group 1 hydroxide, also very common. I now want to cover a little bit from year 7, from the pH scale. Okay, so I don't want to make my pH scale. So now, can I just point out, I'm being very careful and very selective over what I want here, guys. Yeah, I'm being very selective. So you guys probably learned in year 7. Now, I teach, and can I just say, by the way, that I do feel bad about this. I lie very rarely, but at year 7, I do. I'm really sorry, year 7s. I do lie to you. Yeah. In year 7, I do lie and I tell them that the pH scale goes from 1 to 14. Yeah, I do that. And that's actually not true. That's key stage 3. The reason being is students have trouble dealing with numbers that are 0. They think 0 is less, and I get that, when in fact it would be more acidic. Yeah, so then when you get to year 10 at GCSE, this is key stage 3, you then get told that the pH scale actually goes from 0 to 14, and that this is the most acidic. Yeah, acid, basic, acidic, basic. Yeah. In reality, year 10, I'm very sorry, you then get to year 13 at A2. This is GCSE. And you actually get told that the pH scale, in reality, really goes from minus 1.5 to minus 14.5. It's kind of how it goes. But I don't want you to know that yet, folks. Yeah, so I'm glad I didn't tell you. My whole life is a lie. Dom, I actually do very little lying to you guys. I'm, as you can see, I show you the lie. Yeah, you can ignore that now. This is a spoiler. Yeah, this is a spoiler for year 13 chemistry. Teachers do nothing but lie. Oh, whoa, Atia. Whoa. That is so not true. Am I lying now? I'm just telling you that you need to know this for GCSE. And that I'm going to change it when we get to A-level. I haven't lied at all. The heart's been broken to what? What about it, uni? You can look that up. Yeah, you can look that up, Tiff, but it has nothing to do with me. I said nothing. And now it's gone. I have no idea. Nothing, Tiff. No, yeah. Anyway. Oh, no, not again. There is another family, but that's way later on. You don't tend to talk about them. They're more of a speciality than anything else. You don't have to worry about it. I need you guys to know that the pH scale goes from 0 to 14 at GCSE. That's what I need. Yeah. 12 pH, minus 12. Oh, no. Oh, no, Atia, don't do it. Oh, you weren't meant to put that on the chat. Oh, Atia. Anyway, it's that that was totally my fault. I'll from now on, I'm just gonna lie to you. It's the last straw. Is there a super base? Do you know what? I'm not going to lie. I'm not entirely sure, Lara. I'm going to say probably. But I didn't really study them very much. A superacid is an acid with an acidity greater than that of 100% pure sulfuric acid. That's correct, Tiffany. Yeah. Oh, God. Let's leave my degree alone, shall we? I don't want to do any more of that. It's gone. I need you guys to learn this. Please learn that one. That's all I need. It exists. I figured it would. The super base. Drop the super base. Man, I don't know why I've become Jamaican. I'm going to stop. Oh, no. Okay, so moving back onto my lesson, I feel like it's ruined. A superbase is defined as an organic compound whose basicity is greater than that of a proton sponge, and its conjugate Ka is what, 12.1. Oh, God, I'm just going to move on. Right, I feel like I'm lost now. It's too late. You have exposed us the harsh reality of the world. Oh, no, guys. Everything comes in layers. It's like an onion. You've got to start off at the middle and you add layers. It's like parfait. Parfaits are delicious. Everybody loves parfait. Pandora's box has all the layers. All of them. It's like a Russian doll. Holy moly, what have I started? Right. Going back to this, please, folks. Right. pH pH scale. Right. I need you guys. Oh, no, no, don't. Oh, helping. Oh. Right. You guys remember all these colors. Yeah, you remember them all. Yeah, you remember all this stuff. Yeah. There aren't many colors I need you to know, but there are a few. Sorry, folks, there are a few that you need to know. That's it. So you need to know that at red, by the way, this is universal indicator. Yeah, this is universal indicator. You guys need to know this stuff. Violet. No, purple. Violet is the flame color. Yeah. Red, HCl, HNO3, H2SO4. Yeah, you need to know those. Yeah. If you're going to predict the color of ethanoic, even though this is a lie, I apologize. Ethanoic, you'd say, is being orange-red. Then you need to know 7, pH 7. Yeah, we know that this is neutral. Water. Yeah. I'm also going to put also seawater. Seawater, salt does not affect pH. Yeah, which means it is also pH neutral. Blue is ammonia. Ammonia has a pH of 11. Yeah, and sodium hydroxide, potassium hydroxide, lithium hydroxide, all at the purple color. Oh my goodness. Lies. Oh, come on, Lara. Come on. Am I lying to you? I'm being good. I'm telling you where the holes are. It's up to you guys if you want to delve into those lies. But I have not lied to you. I'm stressing that. I feel it's very important that I emphasize that. Next. Okay, next. You guys also came across in year 7, you also came across 2 indicators, which you must know for GCSE. So indicators, 3 indicators. First of all, we need to define this. We did this at year 7. A substance that changes color depending on pH. Fine. Your examples. Universal, number 1. Universal, and you know all your colors you need now. Universal indicator has all the colors, shows a scale. Yeah, but not actually, amazingly, trifluoromethane sulfonic acid never lies. Everything is lie. We are all test subjects. Guys, it's not lies, it's oh, Mel, commendation for that. That was amazing. Well done. Commendation. I'll add that to your thing for you. So universal indicator has a scale. We've already seen it. We've got another one. Phenol, P-H-E-N, P-H-T-H, phenol, A-L-E-I-N, phenolphthalein. You need to know this one. Now, phenolphthalein is pink. And by the way, it is Barbie pink. Barbie pink. Yeah. Barbie pink in alkali. And it is colorless in acid. Got to know that one, folks. Got to know that one. Next one. You should have also in year 7 come across methyl orange. Methyl orange, if you want to say it in French. Litmus. Oh, I'll give you litmus too. Litmus 4. Litmus. Methyl orange is red in acid, It's actually in universal indicator to give it the red color, just so you know. It is red in acid, and it is yellow. Yellow in alkali. Can anyone guess why it's called methyl orange? Litmus, there are two colors, blue litmus and red litmus. And you know that they're two different things. Blue litmus tests for, it is orange. Well done. Orange when, Ryan? Well done. It is orange when neutral. Orange. Orange at neutral. And it's exactly 50-50. Cool. So you need to know these indicators. You should probably remember a lot of them. Middle of orange and red. Orange and yellow. Yeah, absolutely. So we've covered the indicators from year 7. Is there anything? Yes, there is. Next part of year 7 is symbols. Symbols. So acids and alkalis have two symbols. Number 1 is this one. Do you know what? That's just not good enough. I have the internet. I can do this. Go away. Oh, irritant. Irritant. Symbol. Irritant symbol. Won't it turn yellow for alkali if it's in universal indicator? Universal indicator is made of about 6 different indicators, Libby. It's all a mix to give all different colors. Irritant. That's what I want. There you go. This is where I just literally want to just steal that copy image. There we go. Wowza. Is that all I get? Irritant. Now, that irritant symbol is incorrect. The irritant symbol has an I. I need to remember which corner it's in. I never like it. It's on down the right-hand side. So the irritant symbol has an I here, folks. Just letting you know. There you go. That's irritant. The other one, of course, which you guys will recognize is corrosive. 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 Corrosive symbol. Imble. Corrosive imble. I love a good imble. Meta indicator. Oh, no. Stop it. I call this game. There you go. Corrosive, guys. That's the one you need. Copy. No. Copy. Le paste. God, you stupid thing. Paste. Holy moly. That didn't work, did it? Oh, why, hello there. Ooh, yeah. You guys need to recognize these two symbols, folks, from year 7. So we've got corrosive and we have irritant. Now, at this point, students often say, when do you use each one? Le paste. Yes, that's French for the paste. Ouch, my hand. Yes. So just to explain, guys, irritant is used when acids are, these are dilute acids. Corrosive is used in concentrated. Or do you know what? The problem is that people are going to say, at what concentration does it swap over? And that is tricky. Like, if you ever see the word concentrated, it's going to be corrosive. But most acids are just defined as irritants. Then they're not going to like burn a hole through your hands. If they're diluted with water, the chances are they're not going to be. They're going to be just classed as irritants. But Edexcel usually sees these words as interchangeable because they're a bit rubbish. So you know. Suddenly realized I opened up Spotify by accident. Okay. So we picked up our symbols from year 7. We've picked up our acids and bases. We've picked up our indicators. That kind of, we just need to add one more thing. Is there anything else that I need to add here? It's actually, oh, sorry. You're right. We'll stop there, folks. So all we've been doing today, folks, is covering refresher from Key Stage 3. That's all we've done. I will end. Sorry, guys. I don't want to overrun. There you go. I'll bring you back. That one. Oh, I've removed it from the. It's gone. Just do what I'm telling. There we go. Guys, sorry, I didn't mean to overrun. That's my fault. Yeah, it kind of is. Anyway, guys, I will leave you be. We've done the refresher bit from year 7, acids and bases. So what we can now, next lesson, we will start the process of looking at what's actually going on with acids and bases. And we'll look at what happens when they go into water and how they dissociate, and we'll cover that, and we'll draw some pictures, and we'll talk about weak and strong. That's our task for tomorrow. Okay, guys, I will see you guys soon. Have a great rest of your day. Have a nice evening, folks. See you later.